Welcome to the 5th tutorial in this tutorial series, where you're going to be learning how to run simulations using the Federated Learning framework called Flower. In this video, you will learn how to create a custom strategy. Throughout this video, you will learn how you can customize the way your model checkpoint gets saved, so you can save the global model in the way you prefer and in the way that makes the most sense for the framework, machine learning framework you are using. You will learn also how to save locally all the metrics that are generated in each round. We'll be seeing how to save them into a JSON file. And then we'll see how to also take those metrics and send them to a third-party tool like weight and biases or MLflow, so you can visualize how your accuracy is going up and how your loss is going down, for example. This video is going to build on top of what we have seen in previous videos. So if you are new to this series, I recommend you starting from the very beginning. The first video, we saw how you can create a Flower app and run it in simulation, all without writing a single line of code. Without further ado, let's jump into the code. So here I have our code base in the exact same state as we left it. If you remember, throughout several of the previous videos, we have been customizing how our server app behaves. And we have done that by means of a series of callbacks that we have been passing to our strategy. Callbacks are great to slightly customize how the server app works without having to write a lot of code. So if you go, for example, to how the weighted average callback looks like, well, it allows us to make sense out of this metric that the clients are sending back called accuracy. And because we know what it means and we know how we want to aggregate this numerical value, we decided to do a weighted average. Another callback allows us to control what's the learning rate that the clients are going to use on every single round. And there are other callbacks that we have been gradually adding. But now, what we're going to do is going to create a custom strategy built on top of Fedaverage. And this will allow us to customize much more the behavior of our strategy. Because remember, the strategy is the brain of the server app. So let's see how we can create a new strategy. So we're going to begin by creating a new Python file. I did right-click and then new file. And we are going to call this my strategy.py. And here, this new file, what we are going to do first is we're going to import the Fedaverage strategy. Fedaverage is the basis of almost all the strategies. Many of the strategies only differ in comparison to Fedaverage, just in the way the models sent back from the clients get aggregated. So Fedaverage is a good basis for our custom strategy. So we're going to import Fedaverage by doing from flwr.flower server.strategy import Fedaverage. And we're going to create our class that we're going to call custom Fedaverage. For example, you can use another name if you prefer. And then we are going to define the init method. And we are not going to change for now how this init method behaves. So we are just going to call the parent constructor of the parent class, which in this case is Fedaverage. So we're going to pass the arguments. And that's it. We are doing this because later in this video, we are going to add some content to the constructor. If you really don't need to make any changes to the constructor, you can omit writing the constructor for your custom Fedaverage class. What we are going to do is we're going to see how we can save the global model into a checkpoint. So we can save it into our local disk and use it later, for example, to start a different experiment in Federated Learning, or to maybe do some further analysis. So for that, we're going to override the aggregate fit method. So for that, we can do start typing aggregate fit, and it will be auto-completed with all the input and arguments expected. What I'm going to be doing is I'm going to tidy this up a tiny bit, and then I will explain everything we see. So if I don't make any change, this will just behave exactly as Fed-average. So it will receive some input arguments, what's the current round, a list of results. This is a list of the model updates sent by the clients back to the server, and they are going to be used for aggregation. And also, if something went wrong, there will be some failures. But typically, there is nothing wrong, so this is an empty list. And if we are curious and we want to zoom in and see what's actually going on when the parent method of our custom class is called, we can see. And here you have the source code of the Fed-average algorithm, and you can see that what will happen by default is this method will be called, which does the aggregation of all the results. And at the end, this gets converted from NumPy arrays back to the parameters representation, which is the internal representation used in Flower, and it gets returned. And if there were some metrics, which if you remember, we used a callback to define how this should be done, those metrics will be returned as well. So we know that this method is going to return 2 arguments. So what we are going to do is, instead of returning immediately, because we want to customize the behavior of this method, we're going to capture those outputs. And before we forget, we are going to return them like that, so the behavior continues working. But what we are going to do is we want to save, these are the parameters of our global model after aggregation, and are the parameters that will be communicated in the next round of either fit or evaluate. Let's see how we can save them as a checkpoint. So you could save this object directly to the file system, for example, using pickle or any other method. But because we are working with a PyTorch model, let's save it in the standard way of saving PyTorch models. So for that, the first thing we are going to do is to convert this parameter object into a list of NumPy arrays. For that, we can use a utility function from Flower called parameters to ND arrays. Convert parameters to ND arrays. Parameters aggregated, that's easy. And this representation we have here is exactly the same one that you receive when you use a client of type NumPy client. The parameters here is also a list of NumPy arrays, and that is why, for example, this setWeight utility function that we have used in several places, that's why it is implemented in this way. We are simply copying NumPy arrays into the state dict of a model. Going back to our strategy, what we are going to be doing is, first, we want to instantiate our PyTorch model. So for that, I'm going to import the relevant functions. So from task, import net. We are going to import also the setWeights utility function. Instantiate model equals net. What we want to do to keep things fully consistent with how PyTorch works is we're going to apply the weights to our model. Set weights, we're going to pass our model that at this point is just randomly initialized, and we are going to ensure that those ND arrays are integrated into the model, so sort to speak. And now that we have a model with the parameters of our global model, what we can do is save them in the standard way that PyTorch does. So, and probably you have done it in this way in other projects you might have done. So import torch. And what we're going to do is torch save model state dict, and then the name of this file is going to be global model round. And then this is going to be server round. And that's about it. Save global model in the standard PyTorch way. If now I run this app, what we will see is that after every round of fit, once the models, the received models are aggregated to create a new version of the global model, it will be saved to my current directory. So let's see that in action. I'm starting the app. And what we will see is that after every round, a new global model is going to appear here in the directory where I'm running this from. Well, we have forgotten to do something, which is, and that's why it is not appearing, we haven't enabled the use of this strategy. So we need to go back to our server app, which still is using Federated, and we are going to import this new package. So from my strategy, import custom Federated. And we can just keep it like that. So now if we run it again, we should start, after every round, we should see that the global model gets saved to the file system. And indeed, you can start seeing here there is the global model after the first round, after the second round, and then we run it 3 times. So after round 3 is there as well. So that's all good. You could use these models, for example, to initialize the next experiment in your federated learning process. Here, we have a random initialized model, but you could load these checkpoints and ensure that those parameters are the ones passed to the strategy, for example, if that's something you want to do, like, for example, to resume the training. But let's continue from here. What we are going to do now is we're going to see how we can save. We could save to any custom file all these metrics that get logged here. But what we're going to do in particular is we're going to be saving the centralized metrics for loss and for accuracy, which means what's the loss of our global model when it's evaluating on the centralized test set, and what is its accuracy. So we know that we are doing the centralized evaluation of our model by means of this callback that gets passed to as the evaluate function input argument to our strategy. That function, if we inspect the Fed average, for example, if we go to Fed average, which is what our strategy is based on, and we look for when this is being used, we see that this is used in the evaluate method. So this is the method we are going to override. You can find this that I showed here in code, you can find it explained in the documentation as well. So let's override the evaluate method. And again, the signature of this method gets auto-completed. I'm just moving things slightly so it's clearer. So the input arguments is the server round, the current parameters of the global model, and the output is just a floating value, which is the loss, as well as a dictionary of, you guessed it, all the value types that are allowed for the metrics. So let's inspect this method to see what is the expected way of returning from it. You see there are 2 return arguments, as we can identify from this. So let's do exactly as we did earlier with the other method. Let's capture them, and then let's return them so we don't forget. And now, again, if we leave it here, the behavior won't change, but what we want to do is to save all these results into a JSON, for example, that we can later on inspect easily or go back to. So for that, I'm going to do something. I'm going to put all this together into a single dictionary, which I'm going to call my results. And this is going to be loss. And then we are going to copy the rest of the metrics, whatever they are. Currently, we know it's going to be accuracy, but there could be more. So in order to save this as a JSON, the first thing we need to do is to import JSON. And then saving it to a file is fairly straightforward. What I'm going to be doing is just copy code snippet I have here prepared, and we're going to save it just like this. But we could just save it like this. But the problem with this is that we will be overriding the same file with each round. We could, of course, create a new file for every round, just like we do with the global model, but we can do something better than that. And for that purpose, let's go back to our constructor and let's create an empty dictionary that we can update with each round. Results to save. Let's give it that name, for example. It starts as an empty dictionary. And what we are going to do is, let's add a new entry every round. The key will be the round number, and then we save. The value will be this dictionary we have put together here. And then what we can do is we can save this dictionary each time the evaluate method is called, which will be called each time after doing the aggregation. So what we will see is that, yes, there will be one single JSON file that will be updated. It will be overridden with each call to the evaluate method. So let's see that in action. You can see here result JSON has appeared, and then when for round 0, that was the loss and accuracy. For round 1, the loss was a bit lower, but not much. Accuracy didn't go up. But after round 2, things are improving pretty fast. And at the end of the round 3, we see accuracy was 80.22, which is exactly the same as we have here, right? It makes sense. And the loss was 0.544, which if we inspect the loss and centralize, it is exactly the same as here. So this is pretty useful if you want to keep track of your metrics. Of course, we could decide to override other methods in case we want to save to this all the metrics we have here. You saw that in the end, the really new code we had to add was just these 4 lines of code, which naturally you can write them as a single method and call it from all the methods you want to save some metrics. What we're going to do next is, while saving things to a JSON is good, you could decide to save it into something else other than a JSON. It's also very useful when we can export these metrics to some other services that allow us to see them as part of a bigger dashboard. That's really useful for longer experiments where you can track the metrics very easily. You can track them remotely, for example, without having to be connected to the same machine running the simulation. So for that, let's use weight and biases. So I'm assuming you already have a weight and biases account. If not, you can go and create one. What I'm about to explain probably is equivalent to MLflow and any other toolkit to save metrics and create dashboards. It's in TensorBoard, for example, if you use TensorBoard, you would follow pretty much the same steps. So the first thing we're going to do is to install weight and biases. If you recall, in the PyProject.toml, we have the list of dependencies of our app. And although we could do here pip install, we could install weight and biases like this, we are not going to do it because I think it's really better practice if those dependencies are captured in the PyProject.toml. Because, for example, imagine you want to share this project with somebody else, then it's much easier for this other person if they can do pip install and everything, all the dependencies are installed in one go. So let's add weight and biases here. I'm not going to be really fixing any version of it. If now we want to update our installation, we can just do pip install again, as we did in the very first video. Now weight and biases is installed, and what we can do is just follow the typical way of using weight and biases, which is importing it. We need to initialize weight and biases, which that can be done with weight and biases in it. We can give a name to our project, and that is something that I have already done here. So the way I wanted to do it is, let me explain it very soon, from date. Or yes, so what we're going to do is we're going to import weight and biases. We're giving it a name to our project. This seems like a good name for the purpose of this tutorial. And then what we want to do is that each time we start a run, we want it to have a different name, so things are not getting overridden, and also so we can identify easily which run is which. For that, we're going to be calling all the runs custom strategy and then followed by the current date and time. So it will be custom strategy, then what's the current year, the month, the hour, and so on. I think here I'm missing something. I think this is missing here. So this will initialize weight and biases the moment my strategy gets constructed. Now, if we want to save those same metrics that I'm saving here as a JSON, if we want to push them to our weight and biases run, we will be using, let's not use the word push, let's use the word log to weight and biases. Log, and then what we are going to be logging is these same metrics, and we're going to record what is the current server route. Just as simple as that. If we run it, the project again, you will see that there is a bit more logs being generated because of part of weight and biases. If this is the first time you use weight and biases in your machine, you will be asked to log in. That's a very easy process you can follow. You can follow the prompt you will see printed in your terminal. Because I have already logged in, everything runs smoothly. And you can see that the project proceed as you would expect, but there are some additional messages being displayed from weight and biases. So what I'm going to do is I'm going to click into one of them, this one that points me to my project. And if I go there, it will open the weight and biases dashboard, and I can see that indeed there is one run that I just ran. It's now 7:06 in the afternoon, so that sounds about right. You can see the loss going down, and you can see the centralized accuracy going up. Remember, this is the centralized accuracy we saw here. And let's double check that everything is correct. Centralized accuracy at round 6 round 3 is 80.96. So if we double check here, indeed, you can see 80.96 being printed there. So that's amazing. The great thing of having this now connected to weight and biases is that, for example, let's say I want to run it again. Remember, from we saw it in earlier videos, you can override the config, the run config very easily. So for example, let's change the number of server rounds. Server rounds, let's put it to 5, for example. And the good thing is that now, of course, everything is going to work just as before, but we're going to be able to see how this second round, how our federated model, how differently it behaves if it runs for a bit longer. Would it get a better centralized accuracy? It is likely that it will, but let's see. So if we refresh this page, indeed, we can see that the second model ran just a little bit over 2% higher accuracy. And this is everything I wanted to show you. You saw how easy it was to extract these metrics from the methods that are generating them. We can, following a very, very simple process, we can save them locally as a simple JSON that, even though it's simple, it is in fact very readable. You can later on use this JSON to create plots or to further analyze your results. We can right away log them to weight and biases. The only thing we had to do was to initialize our project and to ensure that we have installed weight and biases and we have an account for it. We also saw how we can save the global model of our federation. And because we are using PyTorch, here we did it in the PyTorch way. If you were using TensorFlow, you would need to follow an equivalent process, but instead of calling torch save, maybe you would follow the preferred way of doing it with TensorFlow, whatever that is. So this is the end of this tutorial where we learn how to customize a strategy. You saw it was fairly straightforward. Of course, you can customize it further. Maybe you want to control where all these global models get saved. Maybe you even want to push these global models to weight and biases. And as I said, you could use any of these global models to then initialize the global model of subsequent experiments. The content that you have seen here is already present in other examples in Flower. For example, here I'm in the Flower repository, and if you go to examples and then you go to advanced PyTorch, here you will have an example where you can see a slightly different way of doing exact same thing. How to save the model checkpoints, save the metrics, log them to weight and biases, and a bit more things like, for example, implementing learning rate decay, which is similar to something we have implemented in earlier videos. As mentioned earlier, this video, the code we presented in this video, in this tutorial series, is linked in the video description below. Make sure you check it out. If you have some questions, you have some doubts, and you have some suggestions on how to improve these tutorials, or if there is something new you would like to see a video about, let us know via Slack. You can see the QR code at the top. So if you haven't joined already, please join. So now this video is done. I'll see you very soon in the next video, where you will learn how to make your clients stateful. That is really important if you want to design more advanced federated AI simulations and applications in general. So see you soon.